So in the previous video we covered 3 continuity rules, so we're going to start this video with rule number 4. And that's that the function sine of x, should be an x here, and cosine of x are continuous for all real values of x. For all real x. And I did mention this graphically. I kind of explained this graphically in a previous video. The next one is that the exponential growth function f of x equals a to the x, where a is some number greater than 1, is continuous for all real values of x. And bear in mind that this includes the natural exponential growth function f of x equals e to the x, which occurs a lot in nature. The next rule is that f of x equals log base a of x, so this is your generic logarithmic function. Remember that the base has to be some number greater than 1, is continuous wherever it's defined. So where is this defined? Well, you can't really raise a number greater than 1 to any exponent and get a number that's 0 or less than 0, right? So I don't know, if you raise like 1.5 to some number, even if you raised it to negative a billion, so even if you raise this to negative a billion, there is no way you would get 0 or a negative number. This would just be some tiny fraction. So when is this going to be defined? It's going to be defined for positive values of x. So x greater than 0. And similar to the case of the exponential growth function, remember that this includes a natural logarithmic function f of x equals ln of x, which once again arises a lot in nature. But what if we want to answer the question as to whether f of x equals sine of x plus x to the 9th over 3 times the square root of x minus ln of x all over x plus 4 is continuous at x equals 4? Well, this next rule is going to enable us to answer that. And we're going to call this rule continuity of constant multiples, sums, differences, products, and quotients of continuous functions. So let's suppose that f and g are both functions of x that are both continuous at the value x equals x naught, and c is some arbitrary real valued constant. Then we can make the following, we can be sure the following 5 items here. First is that c times f of x is continuous at x naught. So this is just a constant multiple of the function f of x is continuous at x naught. So in other words, if we know that f of x is continuous somewhere, then we know a constant times f of x is continuous at that same spot. Second statement is that the sum of these continuous functions f of x and g of x is also continuous at x naught. So if we know that f and g are both continuous at a particular spot, we know that their sum is also continuous at that spot. The third is that the difference of f and g is also continuous at x naught. So if we know that, say, f of x and g of x are continuous at x equals 5, we know that f of x minus g of x is also continuous at x equals 5. And we can make a similar statement about the product. So we know that if f and g are both continuous at x equals 5, we know the product is also continuous at x equals 5. And we can do the same thing with the quotient f over g, but with the caveat that x or g of x naught cannot be 0. So again, this is precluding division by 0. So how can we use that in tandem with all the other rules we know so far to answer this question as to whether f of x equals sine of x plus x to the 9th over 3 times the square root of x minus ln of x all over x plus 4 is continuous at x equals 4? Well, we know sine of x is continuous at x equals 4 because it's continuous everywhere, right? We know the numerator here, x to the 9th, is continuous at x equals 4 because x to the 9th is a polynomial function with a positive integer valued exponent for x. we know that the square root of x is continuous at x equals 4 because it's going to be continuous wherever it's defined. It's defined for all positive values of x. If that's continuous, then 3 times the square root of x is continuous at x equals 4 because it's just a constant multiple times a function, times a continuous function. So that's this rule here. We know that ln of x is continuous at x equals 4 because we know all functions of the form log base a of x are continuous wherever they're defined. Ln of x is defined for positive values of x, so we know this is continuous. Okay. Oh, back to this one. We said that we know the numerator is continuous because it's a polynomial function. We already spoke about the denominator. Well, this quotient here, we know it's going to be continuous at x equals 4 because at 4 the denominator is not 0. Remember, quotients of continuous functions are continuous provided the denominator is not 0. The denominator is going to be 3 times the square root of 4, which is 6. So we know this quotient here is continuous. So if we know sine of x is continuous, this function here is continuous, and that ln of x is continuous, we're going to have the sum and difference. We're going to have sums and differences of these three functions. So sine of x plus this function minus this function. So we know that has to be continuous because sums and differences of continuous functions are continuous. And finally, we know x plus 4 is continuous because this is just another polynomial function. And it's continuous for all real numbers, so it's going to be continuous for x equals 4. When you plug in 4 to this denominator, it is not 0. So we have a quotient of two continuous functions wherein the denominator is not 0. So this is going to be a continuous function at x equals 4. Suppose we wanted to figure out where x, or suppose we were asked where f of x equals x to the 5/3 is continuous. Well, in this video we've covered where functions of the form g of x equals x to the n are continuous. We've also covered functions of the form h of x equals x to the 1 over n. But where is this continuous? This doesn't seem to fit. And remember, n's a positive integer here in both of these cases. But this doesn't seem to fit either description. But hopefully you recognize this. F of x equals x to the 5/3 as the composition g of h of x, where g of x is x to the 5th and h of x is x to the 1/3. So if you look at g f of x equals g of h of x, well, you do h of x first, right? Raise x to the 1/3. And then you apply the function g to h of x. So this is equal to g of x to the 1/3. Well, that's going to be x to the 1/3 to the 5th power. And that's x to the 5/3. And we are going to be speaking about continuity of compositions. That'll be the next topic that we're going to discuss. So when we do that, you will be able to answer questions of this form.